What's going on today, guys? I want to talk to you guys about some different robotic welding systems and the different types of robotic welding systems that you see in the market. Hi, welcome back to the Elite Automation YouTube channel. I'm Malachi Greb, your host and CEO of Elite Automation. So we deal with automation related. We build and design automation equipment. So I'm going to talk about two specific types of robotic welding systems, one being Robotic Weld Cells and the other one being Robotic Weld Lines. And I'm going to start off with the Robotic Weld Cells, and I'm going to start with the one that is the, let's say, most advanced of the systems or the most capable of the systems. So the first type of system is a robotic weld cell that generally has multiple robots within the system, and it also has a turn-in with two additional axes. So what the turn-in is, it gives you the ability to rotate in this orientation, and then there's an A and B side, which also have the ability to individually rotate. So your fixtures would get mounted on your A and your B side, so you'd have a fixture 1, fixture 2, and you can rotate that with the robot. Generally, it utilizes the robot's auxiliary axes to rotate those additional axes. So the reason why you would utilize a system like this is for the ability to have a better reach and the ability to have the capability to reach. Maybe you need to perform a weld on the top of a robotic weld fixture. You may need to also flip that robotic weld fixture over and then perform some welds on the bottom side. Now, one other instance that you may have is maybe you need to weld on the top or weld on the bottom, and you can then bring that weld fixture closer to the robot to be able to perform the weld. Or maybe the robot can't reach in a certain angle, so you can tilt that fixture with that 7th axis to be able to hit that weld. So that's one of the largest advantages of those type of systems. Now, when it comes to the number of robots within the system, that is generally based on a few different things. One of the things being your reach. So sometimes the robot can't reach the entire fixture. So even if you put the robot directly in the center of the fixture, it may not be able to reach the top left corner of the fixture, or it may not be able to reach the top right corner of the fixture. So in those instances, you have to have two robots, so that way they can both be offset from the center some and be able to reach the component. Now, one other reason to have an additional robot is cycle time. So the more robots that you have, essentially the faster your cycle time can be. So if you think about it, no matter what in a welding process, you can only speed up the welding process so quick. After that, the only thing you can do is add additional robots to the system to be able to perform more welds simultaneously to then increase your output of the system. So now we're going to go to the second system down from that. And that system is going to be a somewhat similar system, but instead of having a turn-in that rotates vertically, you have a table that rotates horizontally. And so the horizontally rotated table, really the biggest difference from this type of fixture is that it doesn't have two auxiliary axes on each side. Or generally you don't go with this type of setup if you need additional auxiliary axes. So this is also tends to be a lower cost solution just because the overall mechanism of the rotary table is a lot more simple than an entire turn-in that is a much larger structure and have multiple gearboxes on it. Again, this system has the ability for you to have an operator on the outside of the cell. You load your parts into the fixture, you step outside the cell, you cycle start it, it then rotates inside to the robotic weld cell where the robot starts to perform its welds. While the robot is performing its welds, the operator will then load the other set of fixturing with its child parts, step outside the cell, get the go signal again, and then as soon as those child parts are done being welded on the inside, it will rotate out, the new parts will rotate in, and the robot will continue its welding process. So that's how these type of robotic weld cells will generally work, with a turn-in type of system or a table type of system. So now going to the next level down from that type of system, and this will be a singular robotic system, and will generally have some type of table or automated fixturing, but there's not really a turn-in. If there is a turn-in, the turn-in is actually more of just an auxiliary axis. So as I was just mentioning 1 second ago about the having an auxiliary axis where it rotates while the robot is moving, maybe you have some type of part that you need to move and perform a continuous weld on the part, but you don't want to have a bunch of robot motion. So you can actually take, let's say, a cylindrical part and do a continuous motion and the robot actually not move from its position. Maybe all it's doing is its weaving operation, while the 7th axis does its rotation to give you one full continuous weld without any stopping. All right, so that kind of wraps up the robotic weld cell side of things, and we're going to jump into the big systems, robotic welding lines. One way to kind of think about a robotic welding line versus a robotic weld cell is a robotic weld cell is an individual cell with 1, 2, 3 robots in it. They're generally right in alignment with one another, or maybe like some type of symmetrical configuration with one another, right? And they're all performing a welding operation on one particular fixture. Whereas a robotic welding line is going to have a lot of robots in it. It's also going to have material handling robots or material handling devices such as conveyors, shuttles. Again, robots could be within the system, or even the welding robot might have a material handling tool on it, so it can also do the welding and the transferring of the component. And the reason why the transferring of the component is just within a robotic weld line is because you're moving through different weld stations. Now, another thing that is also unique about this is you might have sub-assemblies, right? So maybe you have, stations 1, 2, and 3 are all one sub-assembly together, and maybe stations 4, 5, and 6 are another sub-assembly. And so that's why there's a material handling operations. Maybe the robot's actually handling the picking up of assembly 1 and assembly 2, and then performing those welds, or handing that off to the robot that does those welds. And also a robotic welding line, one thing that you may see that you wouldn't see inside of a robotic weld cell is maybe there are things like nuts or bolts being added to the component. And a lot of times maybe that's a bowl feeded operation where there's a bowl feeder that sorts and nests all the nuts or bolts into a line where a material handling robot can pick that up, place it, and then another robot perform the welding. Now, there's also variants of this where maybe the operator's still loading in the nut onto the fixture themselves. So you'll see all different types of combinations of these types of systems. And another thing to keep in mind too is like a lot of the systems that I was kind of just explaining before with the robotic weld cells, a lot of those cells will be mixed cells. There are also spot welding cells, but with a robotic welding line, you're going to have multiple different types of welding operations within that. You might have MIG welding, you might have spot welding, you might have laser etching. There are all different types of processes that might be involved in a robotic weld line that would not necessarily be in a robotic weld cell. So this kind of takes me to the next line that's probably a lot more popular to the public, and a lot more people have probably seen this type of robotic welding line. It is called a BIW line, which BIW stands for body in white. And body in white gets its name from the fact that it's a pre-paint process. And what I mean by that is the shell of the body has not went through the paint process. And so BIW line is the building of the shell of the vehicle, meaning the skeleton of the system. So this is generally done at a OEM type of company, and an OEM would be somebody like a Toyota, a Ford, a Chevy. These are all different vehicle manufacturers that are OEMs that will build the final BIW shell, and they will also do the assembly of the vehicle car body. And they'll also do the assembly of the finalized car as well as the painting. So the OEM companies will generally have vendors known as Tier 1 and Tier 2 suppliers that will supply to them, and they will generally supply pieces and parts of the shell. Maybe there's some parts that are for the side body, maybe it's underbody, and these different child parts are then merged together, generally through spot welding, but MIG welding as well, and other different types of operations like riveting. And in these OEM facilities, this is where the marriage of this vehicle is happening. So going back to like what this BIW line would look like, it may consist of a robot picking up a child part, and another robot picking up another child part, and then a third robot picking up another child part. One of the really cool things to see is the marriage process, where maybe you have full robots that have picked up child parts and they're holding them in one location, and then you have multiple spot weld robots that are coming into the side doing pinch welds and welding the child parts of the car body together to make that shell. And so that all things will come away the spot weld guns will come away, the material handling robots will come away, and then you have a shell sitting right there where it's just been assembled, it's just been manufactured, married together, and it's a super cool thing to see. Again, a lot of people I think have been exposed to this BIW type of line or other OEM assembly lines more than they have any of the tier 1, tier 2 suppliers. Tier 1, tier 2, they hide a lot of their stuff. They're also not allowed to share a lot of their stuff, whereas like the OEM, they're the owner of the thing, so they're able to share whatever they want of the inside of their facility. Whereas, like, they don't allow their vendors to share any of the things inside their facility. It's also why we struggle to share anything with the public, or as much as what we do, because so many things are protected by NDAs and which is non-disclosure agreements and whatnot. But again, you're probably seeing these type of systems because the OEM of these vehicles does not care to show these internal processes of their company. And I want to kind of point out one other thing. Majority of vehicle manufacturers are the OEM. And when I say vehicle manufacturers are the OEM, they are Toyota, they are Chevy, they are Ford. Now, there are some small amount of companies that are actually outsourcing this manufacturing to other manufacturers, right? So essentially, the vehicle maker is not actually making the vehicle at all. They're literally just stamping their logo on at the end. And they're probably also doing the design of the vehicle, right? So they're involved in the design processes and making sure the vehicle is the vehicle that they want, right? Complete control of the product, but then the manufacturing process is being handed off to other suppliers to perform the entire building process for each individual child part to the fully assembled, completed vehicle. And if you'd like to know any more about robotic welding or anything automation related, we talk about it here on this channel. Put it down in the comments below if there is anything in particular. And we also talk about how to navigate your career through the Manufacturing Come Up, our podcast. Also a playlist here on this channel. So check that out if you're interested in anything career related. And we'll catch y'all on the next one.